Hello students, this video is to help with the Unit 4 problem sets from lessons 5, 6, 7, and 8. Take a look at the lesson 5 problem set, pause the video, try these out, and then see if you got them right. In this case, we're looking for a reflection over a certain line that carries the square onto itself, or rather, which one does not carry it onto itself. All of these lines are lines of symmetry except for x equals 5. It does not go straight through the center of the square, so x equals 5 is our answer. For number 2, it's asking which would not map the rectangle onto itself. If I reflect it across the x-axis, or reflect over the line x equals 4, or even rotate it 180 degrees around that center point, it's all going to map onto itself. However, if I rotate it around the origin, it's going to come over here. That's not mapped onto itself. It's not perfectly overlapping. Here we're looking for the highest degree of rotation. Remember, the minimum degree of rotation formula is 360 divided by the number of sides. Pentagon is 5 sides. This is the minimum degree of rotation, but it's not the highest degree of rotation. All we got to do is add 72 a bunch of times. It's 72, 144, 216, 288, but we never use 360 for reasons that I'll talk about later. In this case, it's asking for the minimum number of degrees again. Remember, the minimum degree of rotation formula is 360 divided by n. In this case, that's going to be 72. This is asking for minimum. This is asking for highest. That's why these answers are different. Which regular polygon has a minimum rotation of 120? In this case, it's giving us the answer to the formula for minimum degree of rotation. It's 120. That means I have to backwards solve. It's a fraction on this side and a integer on this side. I turn this side into a fraction and I cross multiply. If it's got 3 sides, then it's got to be a triangle. And remember, regular triangles are equilateral triangles. They have the same size sides. We're looking for the difference here between the measurements of the regular octagon's minimum degree of rotation and a regular square's minimum degree of rotation. That means I solve for an octagon, that's 45. I solve for a square, that's 90, and difference means subtract, so I subtract the 2. Excellent. The next page is here. Pause the video, try these out, and then see if you get them right. This star isn't a regular polygon, but it can be turned into a pentagon by connecting all the points. And now that it's a pentagon, we know it's got 5 sides, so 360 divided by 5 is equal to 72. If we're trying to find which rotation measures carry the shape onto itself, that means we're going to take that minimum degree of rotation and then add 72 to it a bunch of times, but not 5 times. We add it up until that last side, because if we added 72 again, we would get 360. We never say 360 is a valid degree of rotation to carry a shape onto itself, because any shape when rotated 360 degrees is carried onto itself. So we don't say 360 is one of those degrees of rotation. Same thing here. We take the star shape here and connect all the points. It's an octagon, 8-sided shape, which means 360 divided by 8 is equal to 45. This is our minimum degree of rotation, and then I add 45 to it a bunch of times until I get to 315. Why didn't I keep going? 315 plus 45 is 360. Can't use 360. Here's a triangle that we were asked to graph, and then we were supposed to reflect it across the line y equals 3. It didn't change the triangle very much because that line is a line of symmetry for this triangle. So it maps it onto itself. That's what it says down here. And then we're supposed to reflect over x equals 3. This is that line, and it is still overlapping a little bit, but it's not a perfect overlap. You can notice that it is on top of, but not completely covering. These are 3 different reasons that you could say that it's carried onto itself. They're all going to get you the same number of points. For number 10, it's giving us a square to graph, but then it's just asking the minimum degree of rotation that would carry the square onto itself. Actually, all the degree measures that would carry the square onto itself. So I find the minimum degree of rotation, which is 90, and then add 90 to it a bunch of times until I get to the penultimate degree of rotation. I don't add another 90 because that would give us 360. Here's lesson 6. Pause the video, try these out, and then see if you got them right. All right, for this first problem, it's asking us to dilate by a scale factor of 2. Let's say that this is the center of dilation and that this is the line segment. When we dilate by a scale factor of 2, 2 things happen. First thing that happens is that it gets longer. It gets twice as long. Scale factor of 2 means I multiply by 2 of the measurement. The second thing that happens is it gets twice as far away from the center of dilation. This center of dilation is not on the line, which means the distance between the center of dilation and the line gets twice as long. All right, looking at this, we also know that this line segment and this line segment are parallel. They have the same slope. That means they're not perpendicular, so we cross off both of these perpendiculars. I know that it's going to be choice 3 because it's twice the length of the given line segment because I'm multiplying by 2, and the line segments are parallel. For this one, again, we're given a scale factor and we're given something to dilate, but this is a linear equation. I'm solving it for y equals mx plus b, the slope-intercept form for ease of use. And I know that the point, this origin, this center of dilation, is not on the line. I know that the y-intercept is negative 0.8. It is not 0, 0, which means since the point is not on the line is going to move. Just like what happened here, the line moved farther away. That's going to be the same thing here. So that means it is going to have the same slope. It's parallel, but it's not going to have the same y-intercept. It's going to have a different y-intercept. There you go. Question number 3, it gives us the endpoints of an image, and we're asked to figure out something about the original pre-image. The dilation is 1/2, which means I've taken whatever it was and I've turned it into something with a distance of 20. I used the distance formula to figure that out. Well, if the length of the image is 20 and I multiply the pre-image by 1/2, that means the pre-image is going to be twice as big. That means the correct answer is 40. A 3-inch line segment is dilated by a scale factor of 6. Well, that's easy. 3-inch line segment, dilated multiplied, scale factor of 6. 3 times 6 is 18. Bada bing, bada boom. The triangle ABC is the image of, A prime, B prime, C prime is the image of ABC after a dilation of 2. Remember, dilation makes it bigger by 2, but it doesn't change one thing about the triangle. Notice that this triangle and this triangle are different sizes, but the angles are the same. That's a huge concept that you need to know. Remember that all the angles of a triangle have to add up to 180 degrees. Well, even if you make the triangle super big, the angles still have to add up to 180 degrees. So this angle happens to be 90 here. This angle also happens to be 90. I've made the triangle bigger, but the angle measurements stayed the same. So the measurement of angle B is equal to the measurement of angle B prime, regardless of what happens to the actual sides. For question 6, it gives us area of 6 and perimeter of 12. So I just made up some triangles that meet that criteria. If it's got an area of 6 and perimeter of 12, it could be a 3, 4, 5 right triangle. 3 times 4 is 12. 12 divided by 2 is 6. And you know that the area formula for a triangle is 1/2 base times height. You also know that 3 plus 4 plus 5 is equal to 12. That's our perimeter. The triangle is dilated by a scale factor of 3, which means all the sides get 3 times as big. 3 times 3 is 9, 5 times 3 is 15, 4 times 3 is 12. The area and perimeter are very easy to find just by adding all 3 sides, 9, 12, and 15. The perimeter should be 36. And then 9 times 12 is 108, divided by 2 is 54. There we go. Later on, we're going to do a description of exactly why the area and the perimeter change in different ways. Line y equals 3x minus 1, which is graphed here, is transformed by dilation. Scale factor of 2 doesn't mean much in this case because we're not increasing the length. You can increase the length of a line because a line is infinitely long. So twice infinity is still infinity. But we're really concerned about this center of dilation. Since the center of dilation is on the line, that means the line doesn't move this way, doesn't move that way. It doesn't move at all. The center of dilation being on the line means the line does not move. So the equation is still y equals 3x minus 1. Moving on to the next page of this problem set, pause the video and see if you got these right. Dilations are pretty straightforward. You multiply the scale factor or the number of dilation by all of the x and y values in order to get the new x and y values. For example, negative 3, 2, I multiplied by 0.5 and I got negative 3 times 0.5 is negative 1.5. 2 times 0.5 is 1. And I did that for all of the x's and all of the y's. Dilations are pretty straightforward, as I said. Same thing here. I'm multiplying all of the numbers by 2. The original is negative 2, 1. The new is negative 4, 2. Here the dilation is 1/4, so you can either multiply by 1/4 or divide by 4, whichever is your pleasure. 1, 3 becomes 0.25, 0.75. Not too bad. Use your calculator. You can figure it out. Question number 9, it gives us a triangle and it asks us to graph it. That's this red triangle here. It also asks us to calculate the area. 1/2 base times height is going to do it for us. And I just counted boxes to find 3 and 4. In order to find the perimeter of ABE, I found the length of B to E, that's 5. I know this happens to be a 3, 4, 5 right triangle, but I could have also used the Pythagorean theorem or the distance formula. It's up to you, whatever method you want to use. But anyway, the perimeter is going to be 12. If we dilate the triangle with a scale factor of 2, that means the triangle becomes twice as big, lengthwise anyways, and then the area is going to be 24. Notice that the original area is 6, this new area is 24. Wow, that's much bigger. But the perimeter becomes not 12, but 24. That means the perimeter gets multiplied by 2. The area gets multiplied by 2 twice. Here's why. I know that in my area formula, I have one of the sides, which is the base, and one of the sides, which is the height. Base times height. Both of these get multiplied by 2. 3 becomes 6. 4 becomes 8. which means I'm multiplying by 2 twice. You should think about that when you're doing a dilation. The perimeter is going to be multiplied by 2, but the area is going to be multiplied by 2 times. Here's lesson 7's problem set. Pause the video, try these, and see if you get them right. I'm telling you right now, you must memorize these rotation and these reflection rules. No two ways about it. You should make index cards for them. They were on the index card list. You should also try to memorize them, without even looking at the index cards. The image of point A, which is 4, 2, after this composition of transformations. Remember, we talked about this in class. We're doing this one first and this one second. So the first one, we're going to reflect across the line y equals x. The rule is over here. Then we're going to rotate it by 90. The rule is here. Become familiar with these rules. The image of point 1, 1 under first a rotation of 90 and then a reflection across the x-axis. Just use the rules. You should be fine. For number 3, describing the transformations, these descriptions could change. I mean, you don't have to do the same exact sequence of transformations. In fact, sometimes there's multiple different ways to transform a shape into another shape. Luckily for you, any correct answer is going to be accepted. So if you want to rotate it first and then reflect it, or if you want to reflect it first and then rotate it, most of the time you're able to interchange those and you're fine. Most of the time, I say. For question number 3, you graph the 3 points, and then it asks you to first reflect over the x-axis, that's this red shape here, and then translate it by sliding it left 3 units and down 4 units. Super easy, super straightforward. Write these out instead of graphing it is my suggestion. You could graph it if you want to, but if you make a mistake on the graph, it's going to be marked wrong completely. So I would write these out instead. Moving right along to the next page of the problem set, pause the video, try these out, and then see if you get them right. Okay, the first thing we got to do is reflect across the y-axis. That's ABC goes to A prime, B prime, C prime. Then we got to reflect over the x-axis. That's here. If I had simply taken the shape and rotated it 180 degrees, it would have given me the same thing. Cool. For question number 5, the thing that it gives us is actually an image. The pre-image we weren't given, but we were told that we took the pre-image and we reflected it across the y-axis. So all we got to do is reflect it back over the y-axis. Pretty straightforward. Then we're asked to take this image and then rotate it 90 degrees around the origin. And you should notice that if we reflect ABC over the line y equals negative x, which is this line that goes from the top left to the bottom right, it's going to map ABC onto A prime, B prime, C prime. For question number 6, I drew a diagram to help you visualize it, but another way to do it is just pick a random point and then try to do the 2 transformations to it in different orders. Does the order matter? Well, yeah, because if I do it first y equals x and then our x-axis, then I'm going to get 4, 3. If I first reflect across the x-axis, then I do r y equals x, I'm going to get negative 4, negative 3. Yes, the order matters because the 2 compositions gives us different answers. And then for number 7, it asks us a sequence of transformations that maps 1 onto 2 and then 2 onto 3. From 1 to 2, we slid it, and then from 2 to 3, we rotated it. But not rotated at 90, rotated 270. It should look like this. All right, moving on to lesson 8 problem set. Pause the video, try these out, and then see if you get them right. Okay, we're looking for equivalent transformations here. So the rotation is an equivalent transformation because once I take my random point, which is 3, negative 4, and I first do a reflection across the line y equals x, and then I do a reflection across the y-axis, all I've done is gone from 3, negative 4 to 4, 3, which is the same rule as a rotation of 90. Again, my suggestion is pick a random point. One of the coordinates should be positive, one of the coordinates should be negative, and then see if you could figure it out like that. For question number 2, it's just looking at the shape and trying to figure out the the composition of transformations. In this case, I slid it down and then reflected it over the y-axis. For number 3, it gives us a point and asks us to do that composite transformation, otherwise known as a composition of transformations. It was pretty straightforward to use the rules to figure this one out. And then for question number 4, I want you to notice that from this shape ABC to the shape DEF, the orientation changes. In other words, the way that you name the shape changes. So I am going to have a reflection in here somewhere. It can't be choice 3 or 4. For question number 5, asks us to sketch the reflection, which is like, oh, just draw it. Great. And then for question number 6, name these 2 transformations and then identify the composition. Last but not least, take a look. See if you get them right. As you look over the answers for the last couple of questions, please remember that you should always try to write out all of the coordinates if you're given coordinates for a composition of transformations. All right, these were all the questions from lessons 5 through 8. Good luck studying.